Here we've been presented with C₂H₆, which reacts with O2 and it produces CO2 and H2O. So, okay, this is a reaction of complete combustion, right? But the focus of the question is simply the fact that we've been asked to calculate the mass of H2O that's been produced from this reaction, right? Now, this is a situation where O2 is in excess, okay? Given O2 is in excess, we are in a good position to assume that complete combustion is what took place, we've been told the mass of C₂H₆, which reacted, and therefore we can say, well, C₂H₆ in this reaction is the limiting reagent, right? So effectively, the C₂H₆ is we can use the amount of substance of C₂H₆ which is reacted to work out the amount of substance of the products effectively, because all of the, for example, I don't know, like the hydrogen in H2O would have come from the C₂H₆, right? Okay, so let's try and work out what would be the first step, right? So we want to know the mass of H2O, which we don't have. If we had the amount of substance of H2O, we might be able to work out the mass, right? So the equation would be mass equals moles, the amount of substance effectively, multiplied by the molar mass, right? We can work this out from the periodic table, but the moles of H2O is not something we can directly work out from the periodic table. We need to work that out from the mass of C₂H₆. And so what I'm going to do as a first step is I'm going to work towards figuring out, well, what's the amount of substance of C₂H₆ that actually reacted, because that's going to be very useful in this. In order to work that out, taking this same equation, rearranging it by dividing both sides by the molar mass, right? We can see that therefore the moles is going to be equal to the mass divided by the molar mass, okay? Now, we can work out the molar mass of C₂H₆ using the periodic table, right? So what is the MR of C₂H₆? Well, the MR would be effectively, okay, we need to get the relative atomic mass of carbon, which as we know is 12, right, Cl, and the relative atomic mass of hydrogen, right, which is also, it's also here, right? So that's going to be equal to 12 times 2, right? So 12 times 2, so plus 1 times 6, okay? And that's going to give us the MR of C₂H₆. So if you do work that out, which I would invite you to do, you should find that you get 30. So 30 grams per mole. Now at this stage, we're going to use that in the other equation, right? So to work out the amount of substance. So moles of C₂H₆ is equal to 18.22 divided by 30, okay? And when you work that out, you should find you get 0.607 33, okay? And that's going to be in moles, right? Now at this stage, we also need to look at, well, we do have this value now, but how can we use that to work out the amount of substance for the H2O? Well, let's establish a ratio here. For every 2 moles, this is what I'm reading, this is the balance equation. This is what the balance equation is telling us. For every 2 moles of C₂H₆, we're getting 6 moles of H₂O, right? So the ratio, so the N of C₂H₆, when we look at it as a ratio compared to the moles of H₂O, the equation tells us it's going to be a 2:6 ratio, right? Now, another way to put that, if we divide both sides by 2, is to say that it's a 1:3 ratio. So for every 1 mole of C₂H₆, we're gonna have 3 moles of H₂O. And so what bearing does that have on the amount of substance of H₂O? Well, what that means is, to work out the amount of substance of H₂O, simply put, we can say that the moles of H₂O is going to be equal to 3 times the moles of C₂H₆, which is equal to 3 times, and we worked that out, right? So that's going to be 3 times 0.6073333. Okay, and so if you do work that out, what you should find is you get 1.822 moles, right? So this is actually the number of moles of H₂O, but we've been asked to calculate the mass, right? So it's the mass of H₂O. So there's still an additional step. We need to get the mass from the moles, right? And what's the equation that relates to 2? Again, it's going to be the fact that the mass is equal to the amount of substance, moles, which you have, multiplied by the molar mass, which at this stage we haven't worked out for H₂O, but it's quite straightforward, right? We can refer back to the periodic table again. And we can say again, the relative atomic masses, so H₂O, so it's going to be the MR of H₂O would be, so it's 1 times 2, right? 1 actually, I'm not close the bracket, yeah, plus, and then for the oxygen side, it's just 16. I could write 16 times 1. I'm just going to write 16 on its own, because obviously it's not really going to do much if I put the times 1. And that gives us 18, right? So that's going to be 18 grams per mole. So we now use this 18 with our equation, which we'd worked out here, right? So if we do that, and we say the mass, therefore the mass of H₂O in this question would be equal to 1.822 multiplied by 18, right? And so if you work that out, you will get a mass. And so in this case, this actually would give us 32.796, right, grams. Okay, so but let's refer back to what the question actually asks us for. It asks us to calculate the mass of H₂O produced from this reaction, which we've done, but it also then goes on to say, please answer your question to a maximum of 2 decimal places, which this is 3 decimal places. So an additional step needs to be taken in that we need to round this to 2 decimal places. So if you round this, it's going to be 32.80 grams, okay? And so now this actually adheres to the constraints which is specified in a question as far as how the answers to be formatted. And so this is actually the mass of H₂O that is produced in reaction. All right.